Hello everybody, I'm Nick, and in this video I'm going to show you how .NET 8 finally addresses an issue that has been in .NET since its inception. It is something that many people have tried to solve on their own, and many libraries exist to solve that problem, but now .NET has it built in, and I'm going to show you what that is and why you should care in this video. If you like that content and you want to see more, make sure you subscribe and ring the notification bell, and for more training, check out nickchapsas.com. Alright, so let me show you what I have here. I have a very simple minimal API over here, which all it really has is this greet map endpoint over here, and then a greeter service. We inject that service and we get a message out of it. The message has to do with the time of day. So if I go quickly and run this API and show you what I mean, if I call the greet endpoint, we're gonna get good afternoon, because now my local time is actually 20 past 12. So from 12 to 6, we're going to get good afternoon. And the code for that greeter service is actually very straightforward, what you'd expect. We get the local time now, and then we're checking the hour part of that daytime, and if it is between 5 and 12, good morning, 12 and 6, good afternoon, 6 and 5 a.m. is good evening. And that's all there is to it. Now, many people will see this and say, yeah, this is absolutely fine. And many other people might say, oh, you should use UTC now here. That's irrelevant. It doesn't matter. I'm just talking about time in general here. So you might assume that this is fine, but the truth is, this is not. This actually has a hard dependency here on something related to your machine, in the same way that you would have a dependency to a database or an external API or your hard drive or something in the network. This thing over here is very, very problematic, and I'm going to show you why. If I go to my unit tests, as you can see here, I'm using XUnit and I try to unit test the greeter service. So I have this generate greet text should return good afternoon when it's afternoon test. Now, if I go ahead and I run this test, it all works fine. I can validate that yes, this will execute and return good afternoon. However, if I go ahead and implement all the methods like good morning, good afternoon, and good evening, and I try to run all of them to validate the holistic behavior of this class, as you're going to see, only one test will pass at a time, the other two will fail, because you can only have one time in a given system. So that's why that's problematic, and that's why you're dependent on that system clock. Now, most people know this is an issue. In fact, Microsoft themselves know that this is an issue, and they solve it internally. How? Well, in the same way that I've shown you in this YouTube channel how to solve this very problem. What they do, if we take a look at the source code of .NET, is they have this system clock file over here, but the interesting thing is that they have 7 of them, because since there is no built-in approach to solve this in .NET, each team makes their own. So effectively what you have is an interface which has the datetime offset, which by the way is what you should be using, not just datetime. And if you want to know why, leave a comment down below and I'll make a video. And they have all these interfaces. And then if we search for system clock, you're going to see that every single one of those interfaces has an implementation that all it really does is implement that UTC now property from that interface to the system UTC now or local time now, or in some cases they even implement, from what I've seen, the ticks themselves. So local time zone over here and some all the stuff. So it can get a bit convoluted. So what I've shown in a previous video is how you can solve this problem with that very same solution. However, .NET 8 finally introduces a built-in type to address this. And this type is called time provider. So now you have this time provider abstract class, and it has a system-based implementation. So you can say time provider.system, and now you have access to a bunch of properties and methods. In the most simplest form, what you can do is replace this datetime now to time provider.system.local now if you want that local time. And if I do that, and if I run this code base, then I can run this and I can get good afternoon. Do I want the UTC time? I can say UTC now. And that's how you can use this. However, this wouldn't really fix anything, because if you do it like this, you still have that hard dependency on the system clock, just through a different abstraction. The reason why time provider is awesome is because you can go ahead and just inject it. So you can say time provider over here, inject it from the constructor, and then use it to get the hour. So if I want to say datetime now, I can say local now, and I have it. So what I have to do now is go back to the program.cs, say builder.services.add singleton, and I have to say time provider.system. And now my time provider is implemented in my application through the system clock and injected through my service, as it should be. You should be doing this already, but now you can do it in a built-in fashion. So if I go ahead and I just run this application again, I have the exact same experience. Everything works and we inject the date time. But here's the cool thing about this. I can now go back to my tests and I can actually mock this abstract class to control the time for my tests to validate the behavior. So I can remove this new from here. I'm going to create a constructor and I'm going to create a private read-only time provider, which is going to be a substitute. I'm using n substitute from my mocking for the time provider. And that is it. So now here, all I'm going to say is create a service and then time provider. Now, all I need to do is go to my test and add the arrange section. And I can say time provider.UTC now, because the local time is actually calculated based on the UTC now time. So I can now say returns a time that is within the range I want, in this case, the morning. Now, there's a bit of an issue here because this is not the only thing you need to set up. You also need to say local time zone returns, and you need to also mock that. In this case, I'm going to say time zone info.utc over here. And then I'm going to go ahead and duplicate this in all of the other tests. Now, this is not the only thing I have to do. Because they chose to have time provider be an abstract class, it also has, as you can see over here, a constructor which needs the timestamp frequency, which I'm not a fan of. I don't know why they did it, but you can provide that over here as a parameter by passing down the timestamp frequency from the system. And that is it. I'm going to go ahead and run all the tests. And as you can see now, all of them are passing me because now I can control the date time of the machine. Now, two things I don't like. I don't like that this is an abstract class and it has a constructor. I really don't know why they did that. The idea behind this is sound, and I'm going to link in the description down below to the proposal to see why this was added in the first place in more detail. However, I wish this was actually an time provider and it had a default system implementation. I don't like that it is an abstract class. I don't know why they did that. Now, something else I want to mention is that these are not the only things we are getting in this time provider. We actually get some really nice properties and methods. For example, now time provider has access to two methods that we really needed, and the way to get them before was actually a bit hacky or tricky. So we have this get timestamp now, which is going to give you a system-based high-frequency timestamp just designed for small time interval measurements. And you can have like a start point over here, and then you can have, after all the computation and execution, and end time over here. And why this is great, that's because you now have access to the get elapsed time over here, where you can have a start timestamp and an end timestamp, and calculate the difference in a very precise high-frequency scenario. How precise? Well, if you see how get timestamp actually works, and if we go into the system, it actually uses the stopwatch get timestamp, which is what you would have to use beforehand. Why that's the case? Well, that's the case because the get timestamp in the stopwatch actually interrupts with the OS, with your machine, to get the exact timestamp on your Linux, Mac, or Windows machine, which is way more precise than anything the datetime class can actually provide. So Stopwatch is using that behind the scenes to give you these accurate measurements, and that's what you should really be using. And then the other thing we're getting is we're getting this nice timer over here, create timer, where you can create a timer, pass a delegate, and then have something happen over a period of time. I'm not someone who's really going to use that. I'm going to use these timestamp, elapsed time, and the whole mocking aspect way more, but you should know that you now have this option for the timer as well, if it's something you want to use. But now I want to know from you, what do you think about this? Do you think it should be an interface, and do you agree with the decision of the .NET team to make it an abstract class? Also, how have you been solving this problem for the past years? Were you using your own interface and class combo, or were you using something like Node.time, which already solves that problem? Leave a comment down below and let me know. Well, that's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons for making this possible. If you want to support me as well, you're going to find the link in the description down below. Leave a like if you like this video, subscribe more to like this, ring the bell as well, and I'll see you in the next video. Keep coding.